In this question, we're working with the 2017 AP Calculus AB free response question number 6. As it is question number 6, this one is non-calculator. If you take a look at the prompt here for this one, we've got a table of values for g and g prime. Then we have a graph for h, and also here we have f as a function defined here as cosine of 2x plus e to the sine of x. We're also told that g is a differentiable function, which is good. We've got the table up there. And h is the function above, whose graph consisting of five line segments is shown in the figure right here. Let's work with each part separately, and we'll work through each one and see if we can come up with the correct answer. Part A says find the slope of the line tangent to the graph of f at x is equal to pi. And some key words here are slope of the tangent line, or slope of the line tangent to the graph of f at x is equal to pi. What this means is we need to find f prime, or the derivative of f, evaluated at pi. To do that, we first want to find the derivative of f. So let me just write down f of x here as a reminder. We'll scroll up just a bit. So we've got the cosine of 2x plus e to the sine of x power. And what we want to do here first is we want to figure out what f prime of x is. Here we see a 2x on the inside of the cosine, so we need to use the chain rule here. The derivative of the cosine is negative sine. We keep the inner function, then multiply by the derivative of the inner function, which is 2. Normally you'll see that written out here. It wouldn't be wrong, though, if you multiplied by 2 on the right-hand side. In the next part, we also need to use the chain rule. So here we have the sine of x in the exponent position, or inside of the e. What we'll do then is we'll take the derivative of e to the sine of x, which is just e to the sine of x, but we need to multiply by the derivative of the function above, or in the function in the exponent position. So the derivative of the sine is the cosine. And you can write it out front or to the right. Either one's okay. Now that we have an expression for the derivative of f, we're going to evaluate f prime at pi. So we'll just do a little substitution here. Wherever I see the x, I'll just substitute in pi. And then we've got e to the sine of pi power here. You'll need to evaluate this a little bit further, and we'll see if we can wind up with a numerical answer. So the sine of 2 pi is 0, so that'll be negative 2 times 0, which will eventually be, well, 0. And then we've got the cosine of pi, which is negative 1. So we're right here. And now we've got e to the sine of pi power. Well, the sine of pi is 0, and e to the 0 power is 1. On the exam, I would probably just stop here. This would be your final answer. It's a numerical answer, and so you're good to go. If you did finish this a little further, your final answer in fully simplified form would be negative 1. How are the points going to stack up for this? You're going to get 2 points basically for that answer, the numerical equivalent of negative 1. So that could be this expression, or right here, you could just write negative 1 down. 2 points for that. This one's a two-parter. Let's move on to part B. In part B, we have k being a function defined by k of x is equal to h of f of x. Here we have a composition of functions. If we're going to have to find the derivative here, we're going to need to use the chain rule. And it does say find the derivative of k when x is pi, or find k prime at pi. To do this, we first need to write an expression for the derivative of k. So we'll take the derivative of the outer function and keep the inner function the same, and this is the chain rule here, times the derivative of the inner function. On the exam, you'll get 1 point for this. This one's a two-pointer, and so you'll get 1 point for the correct expression here for k prime of x. The next point comes from the numerical answer for k prime of pi, which is what the question is actually asking you to do. So let's fill in some information here. We'll need to know what f at pi is, and then we'll need to know what f prime at pi is. Luckily, we already have f prime at pi. That's negative 1. That's right here. And you can use the information from a previous part as long as it pertains to the same question number. So this is question number 6, part B. We can use the information from part A. You don't have to show that work again. What we do need to figure out here is what f at pi is. That's this inside piece right here. So if we think about our expression for f of x, that's going to be the cosine of 2x. So I'll write the cosine of 2 pi plus e to the sine of pi power. So f at pi, the cosine of 2 pi is 1. And then we've got e to the sine of pi. Well, the sine of pi is 0. And e to the 0 is 1. So 1 plus 1 happens to be 2. Now we're going to keep moving on with our derivative expression here for pi. So we got to still have to evaluate k prime at pi. So we'll have h prime. Now we figured out what f at pi is. That was 2. And then f prime at pi, that's from the previous part. So that was -1. So we'll sub that in. And then we're going to take a look at the graph of h here and figure out what the value of h prime at 2 is. So here's 2. And here is h of 2, but we don't want h of 2. We want h prime of 2. So we need this slope right here, the slope of that line. Well, let's see. We've got a rise of down 1 and a run of +3, or a change in y of -1 and a change in x of 3. So the slope of that line will be -1/3. That's the value of the derivative of h when x is 2. Then we'll need to multiply that by -1, and you wind up with 1/3 for your answer. You could stop at this section right here. That would be fine. It's not too bad, though, to multiply -1/3 by -1 to get 1/3. And you got 1 point for that answer, 1/3. Once again, 1 point for this guy right here, and then 1 point for your numerical answer here. And we'll move on to part C. So now we have another new function that's being defined by m here, or m, and then m of x is being defined as g of -2x times h of x. And we want to find out what m prime at 2 is. This is what the question is asking us to do. So once again, we'll have to take m of x and find the derivative there. The very first thing you want to do is you want to see this actually as the product of two different functions. So the first rule we're going to use is the product rule. And the product rule says keep the first factor the same, that's g at -2x, times the derivative of the second factor, plus the second factor times the derivative of the first factor. The first factor is g of -2x, and so we'll need to write g prime of -2x, but there's a different function inside of g. It's -2x, so we also need to use the chain rule and multiply by the derivative of -2x, which happens to be -2. Turns out that you're going to get 2 points actually for your expression of m prime here. And that might be because there's two different rules you need to use here. And the first rule you'll be using is that product rule, and then you'll find that the chain rule applies to the last factor we wrote down there, g prime of -2x times -2. To actually answer the question, we want to figure out what m prime at 2 is. So we'll just take the x out, replace it with 2. -2 times 2 is -4. And then h prime at 2 plus h of 2 times g prime of -4. That's -2 times 2. And then we have to multiply that by -2. So we got a few things we have to figure out here. We're going to need to use the table and the graph to do that. So let's figure out what g at -4 is. So we'll scroll back up to the graph, or excuse me, the table here. And we've got g at -4 happens to be 5. We're actually going to need probably g prime, but we'll deal with that next. So we've got g of -4 is 5. And then we want h prime at 2. Now, if we think about it, we just figured that out. That's 1/3 right here from the previous one. Once again, you can use that information that you've already found. And then we want h of 2. So we're going to go to the graph now. And this is actually going to be the y value here. Well, this y value right here would be -1/3. So the value of the blue point right here, the y value, that y value must be -2/3, and then that would make -1 for this guy right here. So Negative 2/3 is our y value. So we'll go back down to our example and we'll write down negative 2/3, and that corresponds to h of 2 here. So if you want to, I'll draw the arrows for you there. And then g prime at negative 4. So g prime at negative 4, we're going to go back up to the table now. G prime at negative 4 is this guy. So that's negative 1. And we'll go back down to the problem. And we still have to multiply that by negative 2. Now, on the exam, what I would do is I would stop here. Just circle that up, box it in, you're good to go. If you are wondering what the fully simplified version would be, and you'll see this on the grading rubric or the grading scoring guidelines for AP, they'll simplify it for you, but you don't have to. You can just leave it right here with the boxed in version. However, we have negative 2/3 times negative 1, which is 2/3. We still have to multiply that by negative 2. So we're going to have 5/3. And then in this case, we're also going to have, let's see here, plus, oops, and that was a negative 5/3. That's my fault right there. I should have written that before. And let's see where I made the mistake there. Ooh, that was from, I think, the previous line. So for this one, we've got g at negative 4. So that's going to be, let's see here, and then h prime of x, h prime at 2. So h prime at 2 was negative 1/3. That's my bad right there. Should have written that before. So my fault. It wasn't the answer. Scratch that off. H prime at 2 was this guy right here. There's my mistake. So sorry about that. That shouldn't be negative 5. It should be the 1/3. That's negative for this one. So that'll be negative 5/3. And then if we move on with this one, we've got 2/3 times negative 2, which is negative 4/3. Of course, we'd have that negative 5/3, which is negative 9/3, which happens to be negative 3 there. All right, moving on with part D. So in part D, we'll try a different color for you. All right, is there a number C on the closed interval such that negative 5 to negative 3, such that g prime at C is negative 4? Okay, so here we're looking for the derivative of g to be negative 4, and it's over an interval. And we're wondering, is there some x value that actually makes that happen? So for this one, we're going to need to use the mean values theorem. To use the mean values theorem, we want to first state that g of x is differentiable and continuous, and differentiability implies continuity. So kind of restating something, I guess, here that you don't technically have to, but g of x is differentiable and continuous over negative 5 to negative 3. Therefore, the mean values theorem, which you can abbreviate as MVT, so I'll write that in parentheses here, is applicable. So what does the mean values theorem say? Well, as long as that function is differentiable, continuous over the interval, the mean values theorem says that the secant slope between the endpoints, so I'll write that down here as g of negative 3 minus g of negative 5. That's the change in y over the change in x, so that'll be negative 3 minus negative 5. So if you can find that, then there's at least one x value. In this case, our x value is c. So there's at least one c where the slope of the tangent line is the same as the slope of the secant line. So let's try to figure this one out here. We'll go back to the table. We're going to need both negative 3 and negative 5. And we're only looking at g here, not g prime. So we're going to be right here. We've got g at negative 3, which is 2, and then g at negative 5 is 10. So if we take a look at our numerator then, we'll have g at negative 3, which we said was 2, minus g at negative 5 over negative 3 minus negative 5, which is negative 3 plus 5, which happens to be 2. So we've got negative 8 divided by 2, which is negative 4. Now, what does that mean? Well, that means that there is some value of c where g prime at c is also equal to negative 4, or the slope of the tangent line is equal to the slope of that secant line. So we want to answer this question, right? Reread the question if you need to. Is there a number c on this closed interval? So you could say something like, by the MVT. It's useful to state what you're using. So by the MVT, there is at least one. There could be more than one, but there's at least one value for c, or value of c, where g prime at c is equal to -4. And you're going to get points for this by, number one, your expression for the secant slope. So that's kind of like this line right here. And then number two, you're going to get the second point here. So this is a 2-pointer. 1 point for the expression here, the work with the secant slope. The next point is going to be your justification using the MVT. So you have to do what's called invoking the MVT, or the mean values theorem. In this one, if you state MVT, or mean values theorem, and you want to first state that g of x is differentiable and continuous, then you will get the point for that justification.